Okay, a random sample of notebook computers currently on the market has an average price of $507. Assume the standard deviation for the population of the notebook is 63. Calculate a 90% confidence interval and the margin of error for the sample if the sample size were the following. So the first confidence interval we're going to do is with n equal to 30. And it's important to note that we do know the population standard deviation. So since we know that, we will be able to calculate the z-score. So let's look up here and make sure we understand what a confidence interval for the mean is. It's just an estimate around a sample mean that gives us a range about the true population mean. And then our confidence level is the probability that our estimate will include the population mean that we're looking at. So we're going to get started with our confidence interval. So the first thing we want to do is look at the formula here. And the formula for the confidence interval is we have to have the sample mean, which we know the sample mean was given in the problem. The sample mean is 507. And we have to know the z-score. So the z-value for a 95% confidence interval, here's our table here, and as you can see, 90% confidence interval, our z-value is 1.645. So now we know z. And then our last part is the standard error of the mean. So to calculate the standard error of the mean, we're going to take the standard deviation divided by the square root of n. And I'm talking about the standard deviation of the population, which was given to us in the problem. It says the standard deviation is 63. So 63 divided by the square root of n, which is 30. So we will find quickly the standard error of the mean. Okay, so I'm going to erase some of this real quick. We found that the standard error of the mean is 11.50. Okay, so now we know all three components to calculate the confidence intervals. So we're going to do our upper and our lower limit. Our upper limit is just going to be the mean plus your z-value, which is alpha divided by 2, and then your standard error of your mean. Now before we do that, let me explain that your confidence interval is 90. So if you go to your table, let's look at that real quick. Let me see if I can scroll in here. So a 90% confidence level means 1 minus that. 1 minus your confidence level would give you with 0.10. So your alpha is 0.10, and when we're doing a normal distribution, we have what's called two tails on the end here. So on each end, we would have 0.05, so they would add up to 10%. So what I'm trying to explain to you is that your confidence level and your significance level, they complement each other, so they add up to 1 or 100%. So going back, just so we understand where that z-score and why it has that alpha divided by 2, it's just showing you that it's a two-tailed test. So if we want to calculate our upper, we're going to do our mean, which is 507, plus our z-value, which is 1.645, and our standard error, and I think I wrote that, yeah. So your standard error of your mean is, we're going to round to the second decimal place, is 11.50. Now, when you're doing your z-score or your critical z-value times your standard error of your mean, if you do those in your calculator, I want to do those separately. You get 18.9, I'm going to round to the second decimal place. You get 18.92. This number here is what we call the margin of error. So it's our cushion above and below the mean. So this is the number, if we have the mean, we're going to do 18.92 above, and we're going to do 18.92 below. And that's going to give us our interval, and we call that the margin of error. Let's go ahead and get our upper. So we're going to do 507 plus 18.92, and we get 525.92. To do your lower, you can go through all the steps again, or what you can do is just take your mean and subtract your margin of error. That's basically what you're doing. So do 507 minus 18.92, and you get 488.08. So if we wanted to write this in an interval, we would have 488.08 all the way to 525.92. So let's go back to our question here. They want the confidence interval, so we can go ahead and answer our confidence interval for 30 notebooks. We got 488.08 all the way to 525.92. But the second part of the question wants to know the margin of error, and we got 18.92. And I'm going to erase all this so we can see. We got 18.92 for our margin of error. So the next thing it wants you to do is do the same thing, but with 60 notebooks. So let's do that quickly. If I can get my notebook to cooperate here. Still a 90% confidence interval, still the same mean. So our Z, which is 1.645, but our standard error of the mean would change. So let's go down here and do our standard error of our mean, which is the standard deviation divided by the square root of n. And the standard deviation is 63, and the square root of n this time is going to be 60 because we're doing 60 notebooks. So 63 divided by the square root of 60 is 8.13. So this time our standard error of the mean is 8.13. So we're going to do our upper confidence limit level and our lower. So we're going to do the mean plus the z-score times the standard error of the mean. And I'm going to multiply these first because this component gives me the margin of error, how much I'm going to add and subtract. And I get 13.37. So 507 plus 13.37 gives me 520.37. So there's my upper limit. And we know the margin of error is 8.13. And then my lower is going to be 507 minus 13.37, which is 493.63. Okay, so let's look at what happened. We didn't change the confidence interval, and we didn't change we didn't change the confidence level, and we didn't change the standard deviation. So the only thing that changed here was the sample size. So when your sample size increases, your margin of error goes down. Why would your margin of error go down? And why would your confidence interval get narrower? Because the more of a sample you pull, you're pulling more from the population, so you're getting a more precise answer. So it's important to note that when all other conditions stay the same and the sample size increases, then your margin of error is going to go down. So what impact does increasing sample size have on the precision of these estimates? It makes them more precise. So the bigger sample we can pull, the more we're getting from the population. Let me know if you have any